Hey everyone, thanks for clicking on this video. Today we're going to be starting a four-part series where we're going to be talking about Riemann sums and all the different approaches that they take. Now, all the problems in all the videos are all going to be the same. The only difference is the method of Riemann sums. So in other videos, the problems may all look different, but here they're all going to look the same. So you want to look in the playlist for the other videos and just jump around so that you can see which ones you need to look at. So in this video, we're going to be focusing on the left Riemann sum. So here in this problem, we have the graph of x squared. And what we want to do is we want to estimate the integral from -4 to 4. And it says using a left Riemann sum with 4 subintervals. And so if you're asked for n is 4. So that means we're going from here, from -4, over to here at +4. Now with Riemann sums, when you're given a function, you usually want equal subintervals. So that means I'm going to break it here, here at 0, and then here at 2. So these are my 4 intervals. Now, how wide are each of these intervals? That is the delta t, since that's the variable we're using. So that is 2. And so now what we want to figure out is what is L of n, which in this case we want L 4. So we want the left Riemann sum with 4 subintervals. So what we do is we want to approximate this area using rectangles. Now the widths are all the same, but what are the heights? Well, they differ. And when we use a left Riemann sum, what we do is we use the left-hand side of the interval to be the height for that whole interval. So that means from -4 to -2, the rectangle looks like that. From -2 to 0, the rectangle looks like that. From 0 to 2, well, on the left it's 0, so that's not going to have any height. And then from 2 to 4, this has a height of 4. So now what we want to do is we want to add up all of this area, and that gives us our Riemann sum approximation. So 2 times this first rectangle is 16, plus 2 times the next rectangle is 4, plus 2 times 0, that's the height of this one, and then finally 2 times 4 is the area of this rectangle. Now sometimes some teachers, some textbooks, they will have you factor out the width because the width is all the same. So that's 2 times the quantity 16 plus 4 plus 0 plus 4. Either way, you're going to get an area of 48. So on the next one, we still want to estimate the integral from -4 to 4, but now we're using 8 subintervals. So we're still going from -4 to +4, but now we need to break it up into these subintervals here, like that. And so now, since we're using the left-hand side, this is going to be the height for this interval, this is the height for this interval, and so on. Now the width, let's see, there are 8 rectangles, and the width is 1. So now we want L8, is what we want. Now the width of all these rectangles is 1, so there's really not much point in writing 1 times a whole bunch of times. It's going to be a waste of time. So instead, I'm just going to write the height. So that's 16 for the first one, plus 9 for the second, 4 and then 1. And then we go 0, 1, 4, and 9. And so when we add all of those together, we should get 44. So that is our left Riemann sum approximation when we have 4 subintervals. Now the next one, now we want the integral, we want to approximate it from -3 to +1. And we want to use 2 subintervals. So we're going to break it right there. And since we're using the left-hand side defines the height for the whole interval. So it's going to look like that. So n is 2. The width, delta t, is also 2. So L2, that's going to be, well, let's see, 2 times 9 plus 2 times 1, which is going to be 20. There is our Riemann sum approximation for that one. Now, not only can you do this with functions, with graphs, you can also do them with tables. And so here we've got this table, and it's going to be the same for all 4 worksheets. And so we want to approximate the integral from 0 to 120. Now, the first one says using 2 subintervals. So that means I'm going to use the interval from 0 to 60 and the interval from 60 to 120. Now, each of these intervals are 60 units wide. Now, the first interval, I'm going to use the left-hand side, 1.2. And then the second interval, from 60 to 120, I'm going to use 4.7. And so when I add these two numbers together, 1.2 and 4.7, that's 5.9. And when we multiply them, we get 354. Now, the next one says, what if you use 3 subintervals? So in this case, we're going to go from 0 to 40, 40 to 80, and 80 to 120. And in each of these cases, the intervals are 40 units wide. And again, we use the left-hand side. So we use 1.2, 40 times 4, and then 40 times 5.1. And so altogether, that's 40 times 10.3, and we get 412. And then finally, our third one is we're going to use 6 subintervals. So here we're going to go 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100, 100 to 120. So each interval is going to be 20 units wide. And I'm going to save myself a little time, and I'm just going to write 20 times each of these left-hand endpoints. So we're at 1.2 plus 2.8 plus 4 plus 4.7 plus 5.1 plus 5.2 plus 4.8. And all that adds together to become 23. So when we multiply them, we get 460. Thanks for watching this video. Please stay tuned for all the other videos about Riemann sums and any other videos that we have coming out from the channel. Don't forget to click that like button if this video helps you, and to click that subscribe button to stay up to date on all the videos we have coming out from the channel. Thanks for watching, and remember, the best way to understand something is to do it.